All right, sorry about that. I got interrupted. So anyway, as I was saying, if we look here, we may be able to do something with this. Now we know omega contains the period in it, so we can kind of use that. So if we look at this and we say V max is the fastest it was going before it hit the spring. So it hits the spring, right? It hits it right there. It's the fastest it's going. So that's our V max, right? That's from our, essentially the spring is at equilibrium. And then it's going to get compressed 0.083 meters. So that's actually going to be our amplitude. So if we look here, we can go with our V max, which we know, that's our V initial, and that's going to be equal to, instead of A, we can put X and then omega. And then we want this when it's a maximum, so we're going to worry about that when sine of omega t equals 1. So this is all we need, is that right there. So this tells us X times 2 pi over the period is V max, right? And then we can solve for the period. So period, right, V max is actually VI, right? So this is V max as well up here. So VI, so T equals, multiply that over, 2 pi X over VI. All right? And so then we can just plug this in. That gets us the period. Now, if you think about it, the time it takes to come to a rest is how much of a cycle? Well, it starts at equilibrium, right? And it goes all the way over here to a maximum compression. A full cycle would be back to equilibrium, would be back to equilibrium, over here to a full stretch, and then like say it attached on there was a, it got stuck on there with some sticky stuff, and then back to equilibrium. That would be one full cycle. So if you look at that red line, it's actually 1/4 of a total period being done. So once you find this period, by plugging these numbers in, 2 pi 0.083 meters and all the other numbers there, over 1.32 meters per second, then the answer for part B, right, this is all for part B here, is going to be the time to compress, or time to come to a stop is what I said, right? Time for it to come to a stop is just the period over 4. All right, so whatever number you get there, it's going to be 1/4 of that 2 pi times 0.083 meters over top of 1.32 meters per second, just like that. Okay? And that's pretty much it for that one.